Okay, let's finish up 1-8 and have some fun with rational inequalities. And remember, rational just means in the form of a fraction. So the concepts of key numbers and test intervals can be extended to rational inequalities. To do this, use the fact that the value of a rational expression can change sign only at its zeros, the x values for which the numerator is equal to 0, and any undefined values where the x values where the denominator would equal 0. These two type of numbers make up the key numbers of a rational inequality. When solving a rational inequality, begin by writing the inequality in general form, which just means equal to 0 or greater than 0 or less than or equal to 0, with the rational expression to the left and 0 on the right. Don't need to see that yet. So example 5, solve this rational inequality. We have 2x minus 7 is our numerator, 3x minus 5, or x minus 5 is our denominator. And the first thing we want to do is set it to equal to 0, or in this case, less than or equal to 0. So I'm going to subtract 3 from each side. So now on the left, I'll have 2x minus 7 divided by x minus 5. And I'm going to subtract 3, and then that's less than or equal to 0. Now comes the fun part. We want to combine this into one fraction. So if I remember, under any number, we could throw a 1. So we're looking for a common denominator. What's our common denominator going to be? If we just multiply these together, that would be it. We multiply each numerator piece by what's missing under it. So here 2x minus 7 has x minus 5. We're missing a 1, so we don't even have to multiply by that. So the 2x minus 7 is going to stay the same. And then this 3 has the 1 under it, but we're missing x minus 5. So we're going to have minus 3, and then we're going to multiply that by x minus 5. And that is less than or equal to 0. Slightly different way to look at that. Here we have just that number 3. And what are we missing is the denominator x minus 5. So we're multiplying the numerator by x minus 5 as long as we multiply the denominator by the same x minus 5. Now the denominator is common here and here, and we multiplied our numerator by that 3x minus 5. And that is all over top of course, x minus 5. So now we just got to do a little basic algebra, simplify that down, and see what our numerator and denominator looks like fully simplified. So we are going to distribute that negative 3. We still got our 2x minus 7. And then we're going to distribute a negative 3 to the x, minus 3x. And a negative 3 to the negative 5. Negative and negative is positive. 3 times 5 is 15. And that's our numerator. And it's all over x minus 5. And that is less than or equal to 0. Combine like terms in that numerator. See, we got a 2x and a minus 3x. That's a minus 1x. And then a minus 7 and a plus 15. That's plus 8. And that's all over x minus 5. Less than or equal to 0. So now we got it all whittled down to a nice simplified fraction. And what we're looking for are the zeros of the function, or where it is undefined. So where does a fraction equal 0? When the numerator alone equals 0. So if we just set the numerator equal to 0, negative x plus 8 equals 0. And I could add, or excuse me, equal to 0. And if I add x to both sides, I'll have 8 equals, that negative x jumps over here and becomes a positive x. X equals 8. That is one of our, these critical numbers. The other one is where the denominator equals 0. This is where the whole function would be undefined. So if I set x minus 5 equal to 0, I get x equals 5. So there are the numbers that are going to chop up our number line. Okay, so we can start to work on our number line now. And we know something important is going on at 8 and at 5. So on the number line, let me put my 8 about here and my 5 about here. Now we got to figure out, do we use brackets or parentheses? And it's not just as easy as looking at here. Here is less than or equal to 0. And, that's fine if we're just talking about the numerator, because numerators can equal 0 and nothing bad's going to happen. It'll just zero out the whole fraction. So because it's less than or equal to, and we are zeroing out the numerator, we're going to have a bracket there on 8. And we're not sure which way it's going yet. I'm just going to put it this way. Just, I can always flip it around if I want to. On the other hand, down here in the denominator, remember what happens if we divide by 0. That's going to, of course, blow up the world, and we don't want that to happen. So that sort of overrules the fact that we have this less than or equal to. You'd think a bracket's going to go there. It's fine if the numerator equals 0, but we don't want the denominator to equal 0. So that's going to overrule the or equal to here, and this will be a parenthesis, because we never want that to equal 0. Now we got to figure out where we have a true inequality. So let me get rid of a little of this work around here. And we're just going to have to pick some test points and see what it does to our simplified fraction there. A little bit over here. So if I pick a number, and make a test interval, how about here, less than 5, let's pick 4 and see what happens. So we're going to take this inequality and plug in 4 for x. So the numerator will be negative x, or negative 4 plus 8, over 4 minus 5. And let's see what happens. Our numerator is going to be positive. Negative 4 and 8 is going to be a positive answer. 4 minus 5 is a negative. If we have a positive divided by a negative, that's equal to a negative. Is a negative less than 0? Yes, it is. So that is going to be part of our solution set. Let's pick a number here in the center slot. Number between 5 and 8. Let's pick 6. And I'll come up here and use blue. So we're going to plug in 6 wherever we see an x. That's going to be a negative 6 plus 8 over 6 minus 5. The numerator in this case will be positive. Denominator will be positive. That means we have a positive net result. Is a positive number less than 0? No, it's not. So that's not part of the solution. And let's see here. We don't want to make any assumptions and just assume this is going to be, but let's check it out. Let's use x equals 9. So just after 8 is 9. My fraction now becomes negative 9 plus 8 over 9 minus 5. And that's a negative numerator and a positive denominator. That divides out to be a negative. And is a negative less than 0? Yes, it is. So this is also part of our solution set. There we go. And that wraps it up. I think that is going to match the books graph pretty well here. Yeah, we even picked the same numbers there. Again, remember, when the divide by 0 scenario, that's always a parenthesis. It is never a bracket, no matter what the inequality has there. All right, example 7. Find the domain of an expression. Find the domain of this function. We have a square root, 64 minus 4x squared. Okay, and let's remember, what do they mean by domain? Remember, the domain are the x values that we're allowed to put into the function without violating any of those big rules of math. And remember, big rule of math, never divide by 0. You don't want to do that. And what don't we want under radicals? Under even indexed radicals, we want no negatives under a radical, if that's an even index, and in this case it is. So the domain here, we're not worried about dividing by 0. We don't have a fraction at all with a variable in the denominator, so we're only concerned about no negatives under the radical. So what is under the radical? What is under the radical must be positive. Must be positive. In other words, greater than or equal to 0. So we can sort of ignore the radical for right now and just take what's under it. We want what is under that radical, the 64 minus 4x squared, to always be positive, or greater than or equal to 0. So let's see. How can we solve this? We could factor out from this side, we could pull out a 4, or we could, another way to look at it would just be to divide everything by 4. We could divide all of this by 4. 64 divided by 4 is 16, minus 4's cancel, x squared. Greater than or equal to 0 divided by 4 is 0. So what can we do next? It looks a little different. You know, what if that was x squared minus 16? Would we know how to factor that? You know, because it's sort of just that in reverse. You know, we're used to seeing x squared minus 16 equals 0. Well, what are the factors of 16 that add up to 0? There's a 0x in the middle, or if we notice that as a difference of squares, it'd be x plus 4 and x minus 4. You know, we're just doing that backwards here. So we want to factor that. Leading term is 16. What times itself is 16? 4. And our next term is x, so it's got to be x times x. One's a positive, one's a negative. And we want to set that greater than or equal to 0. So if we set each individual term equal to 0, if 4 plus x equals 0, then x equals negative 4. And if 4 minus x equals 0, x equals positive 4. So those are our critical numbers, or our key numbers. We know something's going on at those key numbers on the number line. So let's come up with a little number line here. I guess we can move this up. So we know something's happening at 4 and negative 4. If I put 0 here, put 4 and negative 4. And we got greater than or equal to 0. Greater than or equal to means we can use brackets, and we know that's going to be occurring at 4 and negative 4. So I'll put some brackets there, not sure which way to go. Just put them this way for now and see what happens. So if I take a number in between there, 0 smack dab in the middle, I like that. And now remember, we're going back to our original function. I guess I didn't have to get rid of all of that. Right here. That's square root of 64 minus 4x squared. Well, if I plug in 0, I get the square root of 64 minus 0, which is just the square root of 64, which is equal to 8. Is 8 a positive number? Because remember, we wanted what was under the radical to be greater than or equal to 0. Is 8 greater than or equal to 0? Yes, it is. So we do know that is in a part of the solution set. So in between 4 and negative 4 will be that solution set. What if we happen to stray outside? What if we plug in a 5? Or we could look at the same time its negative counterpart, negative 5. Because the same thing is going to happen under the radical. We're going to get 64 minus 4 times. And if we plug in the 5 and square it, we'll get 25. If we plug in the negative 5 and square it, we get the same 25. So that becomes, oops, that's an ugly 5, 4 times 25, or 4 times x squared. That's going to be 64 minus 100, and 64 minus 100 is definitely a negative number. And we don't want negative numbers under radicals. So it's not like this is even could be considered part of the solution set. We would have complex numbers out here. We would not even have a real solution to think about. All right, there's our algebraic solution. Squirrel. What about a graphical solution? Back on the other slide, here when we plugged in, no, that wasn't it. When we plugged in 0, we got an output value of 8. Remember, this is just a function y equals. So if I plug in x is 0 and I get y equals 8, that 8 is our y-intercept. So, and we already found 4 and negative 4 are the key numbers. You know, we were just looking at it one-dimensionally as that straight line with brackets here at 4 and negative 4. If I plugged in 0, I did get a positive output up here at positive 8. So graphically, we know this is going to be a parabola opening down, sort of, but it ends there at the x-axis. So begin by sketching the graph. Again, we found the endpoints 4 and negative 4. The y-intercept is 8. From the graph, you can determine that the x values extend from negative 4 to 4, including those endpoints. So the domain of this expression is negative 4 to 4. A couple of practice problems. These mirror the examples pretty good. In the first one, solve the inequality and graph the solution on the real number line. In this one, find the domain of the expression. Do a little quick sketch graph to verify the result. So pause the videos, give those a try, see if you get them right. All right, in the first one, in the example, we had something like this, less than or equal to 2, and we had to get the 2 on the other side, or whatever that number was, because we wanted it less than or equal to 0. And here they gave it to us ready to go. It's already less than or equal to 0. So what we want is a common denominator. Just like in the example here, we have this quantity, and we have a 1 under the 2. So our common denominator is going to be that x plus 1. But I got my minus 2. And remember, we could look at it this way. I want to multiply this 2 by something to get that common denominator. And it's just the denominator we need, x plus 1. And that is less than 0. So here, we're going to distribute the negative 2. And I'm going to write this all over the common denominator, x plus 1. So the start of it doesn't change. That's just still x plus 6. Distribute the negative 2. Negative 2 to x is minus 2x. Negative 2 to 1 is minus 2. And that is the numerator, and the whole thing is less than 0. Oops. So let's combine some like terms in that numerator and then see what our key numbers are going to be. We got x minus 2x, that's negative x. 6 minus 2 is 4. And that's over x plus 1. Less than 0. So remember, our key numbers are in 2 spots, where the numerator is equal to 0. If negative x plus 4 equals 0, then x equals 4. And where the denominator is equal to 0, if x plus 1 is 0, then x equals negative 1. So we solved the inequality. Now we just got to graph that on a little number line here. See what we got. 4 and negative 1 is where the important stuff is happening. So here's negative 1. Up here would be 4. And let's see, remember the denominator, where the denominator would equal 0 at this negative 1, that is always going to be a parenthesis. And I'm not sure which way it's going to go. I'll put it this way for now. And the numerator is dictated by this sign. And we got our numerator's key number at 4. Less than, we don't have the or equal to, so that will also be a parenthesis. Okay, now let's figure out which way those arrows are going and see if I drew my parentheses in the right spot. Let me see here, what's a good test number? Here to the left of negative 1, let's just do a negative 2 and see what happens. Let me get myself a little more room down here. If I plug in negative 2 into the original function up here, the simplified fraction, I'm going to have a negative 2, which is 2, plus 4 over negative 2 plus 1. And that's going to be a positive numerator and a positive denominator. That's a positive net result. Is a positive number less than 0? No. So that is not part of the solution. Whoa, 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 hold the phone, back up, back up. Can't believe I did that. Negative 2 plus 1, that's a negative denominator. Why didn't you stop me? Positive divided by negative, that is a negative net result. Is a negative number less than 0? Yes, it is. So this is part of the solution. My favorite number lurks between negative 1 and 4. We can plug 0 in and see what the function becomes. We'll have a negative 0 plus 4, which is a 4, and a 0 plus 1 downstairs, which is 1. That's positive divided by positive, which is positive. And is a positive number less than 0? No. So we do not have solutions in between our key numbers. And lastly, let's go to, why not 5? Plug 5 in, that'll be a negative 5 plus 4 divided by 5 plus 1. Or a negative numerator positive denominator, which nets out to be negative. Negative numbers are less than 0, so our solution set picks up over here. Alrighty, good times, good times. Let's see, now we got that second one to do. Let's see, and I guess I'll just save this number line up here for later. In these exercises, find the domain of x in the expression, use a graphing utility to verify. So this is a lot like the example. Again, we cannot ever have a negative underneath a radical. So we are going to take what is under the radical and say that it must be positive or greater than or equal to 0. And here I guess we could add x squared to both sides. So the 4 stays on the left and then greater than or equal to x squared. Now we could square root. If we square root both sides here, we're going to have a positive or negative 2. Don't forget, when we're extracting these square roots, we will have 2 of them, greater than or equal to x. So our key numbers are positive and negative 2. So let's see. Number line time. Here's 2. Here's negative 2. And we have the or equal to in there. So I guess we will have brackets on this. Because remember, we can have a 0 under a radical, just not a negative number. Let's see. And what happens if we do plug in 0? Well, back to the original function, the 4 minus x squared under the radical. If we plug in a 0, we get 4 minus 0, which is 4. The square root of 4 is 2. Is a positive, or is 2 a positive number? Greater than 0? Yes, it is. So our solutions exist between. If we do plug in an outlier point like a negative 3 or a positive 3, we'd get 4 minus 9, which would be a negative number, so those would be complex on the outside of that. So our domain is just negative 2 to 2. Again, anything outside of that, and we get a negative under the radical. Homework for this section, 158, 159, 38 to 41, all of those, 54, 55, and 56, those 3, and then 58 to top it off.